Hello guys, welcome to Solving Solutions, your number one channel where you get solutions to all your solving problems. It's nice having you in class again today. How have you been? We showed you how to multiply matrices. We showed you how to find the inverse of a matrix, and then we also showed you how you can achieve these results using your calculator. So please, this information is very important because in today's video we made so much reference to the previous videos. So if you find this video a bit difficult, do not hesitate to go back to those videos and learn the basics. The links to all the videos related to matrices will be on the description section. Please don't fail to check them out because the foundation you are going to get from there would help you build on today's video. It is very important that you see those videos. Now, without spending much time, we are going to do what? We are going to solve a problem on adjustment computation. We are going to solve a problem today. As you can see now, we are going to find or determine the adjusted value of a line. Now they say given the following data and assuming all observations carry equal reliability and uncorrelated, we should determine the adjusted values of A and D, of AD, of line AD. Now if you, or let's say as a surveying student, you would have gotten to the point where you learned adjustment computation, and then for a little bit of, would I say, introduction or whatever the case is, you know, no observation is free of error. Every observation has a measure of error that we are trying to determine and maybe reduce to the barest minimum. These were some of the basic, would I say, the basic notes they gave to us while we started. And then least squares method of adjustment is actually, would I say, the best, and then it is the most rigorous, and then it's actually the best, the most rigorous and the best. So we are going to use the observation equation method of least square adjustment to solve this problem. The observation equation method of what? Of least square adjustment, least squares adjustment to solve this problem. Now we have the length AD, and then the length was divided into 3. The total length is I think 150 meters. However, there are a little bit of errors, as we all know, when you want to carry out computations on adjustment. So line AB measures 50 meter, line BC measures 50.07 meters, line CD measures 50.05, then line AC, which is a combination of AB and BC, measures 100.09, and then line BD, sorry for that, that should be line BD. Line BD, which is now a combination of BC and CD, measures what? 100.01 meters. Now they said we should calculate the adjusted value of AD, which is AB plus BC plus what? Plus CD. Now it's actually very simple, and it's a bit let's say, it needs your patience. Now for you to use the observation equation method, there are a little parameters, let's say a few parameters rather, you are going to extract. Now from the question given to us, we have 5 observations, right? AB, BC, CD, AC, and what? BD. So those are the 5 observations. We have the first observation here, the second observation, the third, the fourth, and what? The fifth observation. So these are what? The 5 observations we have in this particular question. And then the number of unknowns are actually 3. Now the reason why we say there are 3 is that we want to get 1, 2, 3, which is AB, BC, and what? CD. So upon getting AB, BC, and CD, we can just add them up together and get what? The length of what? AD. The corrected or the adjusted, okay, let's call that the adjusted what? Values of what? Of line AD. So from here we know that M in the observation equation method of least squares adjustment is the number of observation, and it's 5. Then N is what? The number of unknown, and we have 3 here. Then we have a matrix A, which is the coefficient of what? Unknown, and that matrix is actually a matrix of M by N, which is the number of observation by the number of what? Unknown. In this case we have what? 5 by 3, so that's why we have the 5 by 3 here. Now, we will use observation equation as we said earlier. Let's form the observation equation using L to represent the length, which means anywhere you see L, we are talking about the length what AB, BC, CD, or AC and what and BD. So the length one adjusted. Now, before ever you get the adjusted value of a length, you would have the observed value and the what the D, which is the correction to the approximate parameter. Are we together, please? We are trying our best to make it as simple as possible. Now the L adjusted, that's the first length adjusted, which is this one. For you to get the adjusted value of this, you need what? The observed length plus this D. We can just conventionally call it the error, because the every adjusted value, the difference between the adjusted value and the observed value is what? The error, or maybe the, let's say, yeah, the error we are trying to determine. So now, without encumbering ourselves with so much grammar, this is actually the formula, or let's say this is an expression that we are going to use throughout the course of forming the observation equation. So the first thing, as we said earlier, is that what you have the adjusted of L1 equal to what? The observed plus what? The D1. Are we together? Good. So that's the same way we did from L1 to what? To L5. Now, what is the observed value for L1, which is length 1? The observed value is what? 50.000. So we have 50.000 plus D1. Same thing for L2, 50.070, 50.070 plus D2. Same thing for L3, which is what? CD. We have L3 observed plus what? D3, which is now. When you now come to L4, remember that L4 is what? AC. And then AC is a combination of what? AB and what? BC. Therefore, it's now a combination of L1 and what? And L2. Are we together? That's why you are seeing L4 adjusted is equal to L1 observed plus L2 observed plus the error, or let's say, what do you call it again? The correction to what? To L1 and the correction to L2. So by the time you add these two together, which is 50 plus 50.07, you will get something. Now, the most important thing in adjustment computation is that when you are carrying out any calculation, whether in class or personally, you need a calculator by you, and a calculator that you can be able to perform very good, let's say very good calculations with. Now, 50 plus 50.07 will definitely give you what? 100.07 plus those corrections we have, which is D1 plus D2. Coming to L5, L5 is what? BD. This is not BC, sorry for this error. It's BD. So since we have BD, what? That's what? L2 plus what? L3. So what's the value for L2? L2 is 50.07 and then L3 is what? 50.050. So by the time you add the both of them together, you get something like what? 100.02 plus D2 plus what? D3. So these are the observation equation. You have been able to form the observation equation, as simple as that. Now let's form the A matrix. The A matrix, as we told you earlier, is the coefficient of the unknown, which is actually a matrix of what? M by N, and we have what? 5 by 3. Now these are the, the unknown we are trying to get, which is the three unknowns we talked about earlier. So what this D1, D2, D3 represents is that for each of the observation equation, we are going to see which of them has this coefficient. So when you come to equation 1, you would find out that you have only D1, but there is no D2, there is no D3. As you can see now, you have only what? D1. So D1 is 1, D2 is 0, D3 is 0, because you don't have them in the equation. You come to what? Equation 2. You don't have D1, but you have D2, which means D1 will be 0, and then D2 will be 1, and then D3 will also be what? Will be 0, because there is no D1 and there is no what? D3 for this second equation. When you come to the third one, you will see what? You don't have D1, you don't have D2. That's why you have 0, 0, but you have what? D3. So you have 1. You come to the fourth equation now. Remember that the fourth equation was what? Combination of first and the second, like L1 and L2. That's why you can have D1, D2, but no what? No D3. So D3 is now 0. So anywhere you see this unknown, it is represented by 1. And if it is not there in that particular equation, it is represented by what? By 0. Now for the last one, which is L5, which is a combination of what? L2 and L3. So which means there is no L1. So since there is no L1, we have only what? 0 for L1, and then we have 1 for L2, sorry, D2 and what? 1 for D3. Are we together? So this is how you form your A matrix. the matrix of what? The coefficient of the unknown. Are we together? So, and the dimension is what? The dimension of the number of observation to what? The number of unknown. So in this case, we have 5 by 3. Also, the L matrix. The L matrix is given by what? Computed values minus what? Observed values. Now, by computed, we mean when we are trying to add up these composite lines, like these lines that, should I call it composite? So when we are trying to add up these lines that comprises of 2 lengths, we add a value different from what was given to us from observation. Are we together? For line AC now, we add 0.100.09. That's what they gave to us from observation. But when we added it here, we add what? 100.07. So you can see that there is a little discrepancy. Same thing for the L5, which is what? L2 plus L3. When we added it, we add what? 100.12. However, what was given to us is what? 100.01. So you can now see that there are little differences between the computed and the what? And the observed. So for that same reason, we are now going to have a matrix for what? The computed minus the observed. So the first one is 50 minus 50, which means you have 0. The second one is 50.07 minus 50.07, you have 0. The third one is what? 50.05 minus 50.05, you still have 0. Now, this is where you now have some values. Please, you can confirm these values with your calculator. 100.07 minus 100.09, you would have something like minus 0.02, right? Good. Now, the next one is what? 100.12 minus 100.01. You would have something like 0.10, right? So this is now the matrix of L, or let's say this is now the L matrix, which is actually the computed values minus what? The observed values. Now, these are the expressions we are going to use. These are very good expressions that you should always what? You should always remember. So now D is equal to the negative into, now this negative is actually affecting the whole multiplication. So when you have gotten the product, pay attention to this negative because we are going to come back to it towards the end of the video. Now, when you've gotten the product of these two matrices, that's A transpose A inverse multiplied by A transpose L, then you now multiply it by this negative. Are we together? So the formula, or let's say the expressions we are going to use, is that this D equal to A transpose A inverse multiplied by what? A transpose L. And you know that we've already gotten the matrices of all of these rather. So we have the matrix A, we also have the matrix L. Now the next thing is V. Now the V is actually what? The residual. The V is what? The residual. And for the residual, we have what? A times D plus L. So by the time you have the value for D, you multiply it by that your A matrix and you add it to what? This L. So that's why I say keep in view. This is a formula that you are going to always remember during the course of I'm carrying out adjustment computation using the observation equation method. Now let's start the main task of today's video. So since we are using this formula, which is this D, which represents the what? The correction to the approximate parameters, and it says A transpose A. Yeah. So since we have A transpose A, that means A, which is this matrix. If you try to transpose, that means row to column, right? Row to column, row to column, row to column, row to column. So we have 100. Instead of this 100 going this way, it's now coming down. 010 coming down, 001 coming down. So these are just elementary part of a matrix. So by the time you change the rows to column, you have what? The A transpose. Then you now multiply it by the A. Are we together? So this is where you need to go back to some of those videos and you see it. Now in some of those videos, which you are going to see in the description section, the links will be on the description section, you would see how to actually do what? You would see how to multiply matrices manually and how to multiply matrices using your calculator. Are we together? So by the time you multiply these two matrices, you are supposed to get, or you are supposed to arrive at what? This 3 by 3 matrix, which is having 2 1 0 1 3 1 and what? 0 1 2. Are we together? So please don't forget to go back to that video or those videos and then confirm this answer. Now the next part of it is, now we want to get the inverse of that product we got earlier, which is what? The inverse of what? A transpose A. Remember the formula is what? A transpose A inverse multiplied by what? A transpose L. So since we have been able to get the product of A transpose A, now we want to get what? The inverse of that product. Now remember, inverse is simply adjoint over what? Determinant. adjoint over determinant. So the process of, or let's say the procedure of getting to this particular inverse, the link to that video is actually on the description section. So when you get there, you will see how to do it manually, and you would also see how to use your calculator to achieve the same result. Now, extracting the result from doing it with our calculator, we got something like what? This 0.625 minus 0.25, then 0.125 minus 0. So these were the elements we got for what? A transpose A inverse. Are we together? Now the next part of the formula for D, which is what? The correction to the approximate parameters, said we are going to also have A transpose L, right? We already have our A transpose, and then we also have our L. So the next thing is what? We are going to multiply these two matrices. So by the time we multiply these two matrices, we have what? A 3 by 1 matrix, right? So 3 by 1 matrix is minus 0.02, then 0.09, and then 0.11. So this is now actually what? The product of these two matrices. Therefore, to get our D, which is a combination of the first result we had earlier and this other, okay, of this result and this result now. So we are multiplying this A transpose A inverse by this what? A transpose L, which is what we have here. So this is A transpose A inverse multiplied by what? A transpose L. So we are now going to have something like this, another 3 by 1 matrix. Please ensure you confirm these values. Ensure you confirm these values by either doing these things manually or using your calculator. But remember that you do yourself very good, like you help yourself so much if you learn how to do them manually, so that when you get to the exam hall and you are not able to get yourself close to very good calculators, or maybe something happened to your calculator, you can be able to find yourself around it. So the videos or the links to those videos are actually on the description section. Now remember that negative value we told you earlier. So we are now going to use that negative value, which is actually this value you can see here. We are going to use that negative value to open this bracket. So we now have something like what? Instead of this minus here, which is in front of this our first element here, we are now going to open it. So minus times minus will give us plus, and since the other elements of this D matrix does not have minus, it will not have minus, which means the minus has been used to open the bracket. Therefore, the matrix of this our correction to the approximate parameters are actually this. Are we together? Now using V, remember that we also talked about V, which is the residual now, which is actually we are getting to the end, which is the residual. Now V is equal to what? AD plus L. AD plus what? L. We already know our A, which is what? This matrix 5 by 3 matrix. We already know our D, which is what we just got right now, and we knew our L earlier rather, which is the matrix of computed minus what? Observed, which is what you can see here. Now this other part was also summarized. The essence of summarizing it is that we don't want to make this video too long and bulky. Therefore, you need to go back to those videos and see how these things were explained in bits and bytes, so that you can actually get a very good appreciation of this video, because they are actually in a sequence. So now, by the time you multiply these two matrices and you add them to this particular matrix, you'll be able to have a V matrix of this. So this is where you now have what? The residual you are going to apply to what? Each of the observed values. Finally, let's apply this correction to our observed values to get the adjusted values. Are we together? So these were the observed values. Remember that we had for AB we had 50, for BC we had 50.07, for CD we had 50.05, for AC we had 100.09, and then for BD we had 100.01, right? Now plus all this V, like the residual, plus the residual. And you know, when you are adding matrices and they are equal, you can just add directly. So this is actually another basic knowledge. So 50 plus 0.02125 will give you the sum. 50.07 minus 0.0 will give you the next one. 50.05 minus 0. So this is how we came about this value. Now we will now check how to get the corrected distance, which we were asked to find, because they say we should determine the adjusted values of AD. Now, since we have gotten the adjusted values of the components of AD, remember that AD was divided into what? AB, BC, and what? CD. So we are now going to add these three values together. Are we together? These three adjusted values together. So that will be what? 50.0215, 50.070475, and then 50.00625. Good. So by the time please make sure you press these things on your calculator to confirm these values with us. They are very, very important. So by the time you add all of them together, you get something like 150.0725. So approximately converting it to 3 decimal places, we have what? 150.075. So this is actually the adjusted length of what? Line AD, or this is actually the adjusted value of what? Line AD, or this is the corrected or the adjusted value of that length AD we are what? We are trying to get from the beginning. So we hope we have been able to provide solution to this particular solving problem. We are emphasizing that for you to have a better understanding of this video, you don't fail to check those videos before it. And those videos before it are the videos where we showed you how to carry out matrix multiplication, inverse of a matrix, determinant, using your calculator, and also using the manual method. So by the time you see those videos and you also see this video, you'll be able to see or appreciate how we came about some of these multiplications, this inverse and the addition and what and all of them. So as we said earlier, thanks for coming to class. We are going to see you on the next video. So as a student, if you have any challenge regarding this topic, you can always reach out to us, and we are available and willing to provide the needed assistance to you. So until then, keep being good at what you're doing and have a nice time. Bye.